Welcome to the lecture on system characterized by a difference equation using Z transform from the course Signals and System. In this lecture, we will understand how Z transform help us analyze discrete time LTI systems in a simple and systematic way. Let us first understand why we need Z transform. Why we need Z transform. The discrete time systems are usually described by using difference equations. Solving this difference equation directly in the time domain is difficult and time consuming. The Z transform converts these difference equation into algebraic equations, making the system analysis much easier. So what is a difference equation? A difference equation relates the present output of a system to its present past outputs and present or past inputs. It is discrete time equivalent of a differential equation. General form of this concept is the notation is summation of k from 0 to n a k into y of n minus k equal to b k into x of n minus k. Most digital systems and filters are described using difference equations. So, a discrete time LTI system is completely characterized by the first, the difference equation, second, the system function h of z, capital H of z, third, the impulse response, small h of n. Once we know these, the system behavior is fully known. The Z transform of a discrete time signal x of n is defined as x of z equal to summation of x of n into z power minus n. Here z is a complex variable. The Z transform converts time domain signals into Z domain. The Z convert time domain signal into Z domain signals, which simplifies analysis. So only we convert from time domain signal into Z domain signal. Let's important properties used in system analysis of given system. That is, while analyzing system, we mainly use two properties that is named as linearity time shifting property. According to time shifting, z of x of n minus k equal to z power minus k into capital X of z. We always assume the system is initially at rest. Now let us consider an example. We are given difference equation relating y of n and x of n. Y of n, that is y of n minus 5 by 6 into y of n minus 1 plus 1 by 6 y of n minus 2 equal to x of n minus 1 by 2 x of n minus 1. From this, we have to find system function, impulse response and frequency response of given system. We now take Z transform on both sides of the difference equation. That is, if our given system, this is our given system through the difference equation. In this equation, we are going to apply the Z transform logic on both sides, that is left hand side and right hand side. This equation comes like this. This equation comes like this. Small y of n converted into capital Y of Z. Then y of n minus 1 comes like this, z power minus 1 into y of z, like y of n minus 2 written as z power minus 2 into y of z. That is the second order equation. That is y of small y of n minus 2 written as, that is transformed into z power minus 2 into y of capital Y of z equal to capital X of Z minus 1 by 2 Z power minus 1 into X of Z, because our given expression like this 1 by 2 into X of n minus 1 written as like this. here we can take common terms of y of z, and the right hand side we common term taken as capital X of z. So we can take common term y of z here. So our equation comes like this. After taking common terms, we can find the system function, that is capital H of z. That by definition, we know the equation of H of z, that is equal to capital Y of Z divided by capital X of Z. So we have to adjust this term like this, that is capital Y of Z divided by capital X of Z comes left hand side. The other terms goes in the right hand side. So similarly, we can find the concept of system function, equation of system function H of Z equal to 1 minus 1 by 2 into z power minus 1 divided by 1 minus 5 by 6 z power minus 1 plus 1 by 6 into z power minus 2. Now here we can take factorization logic. So we need to take this factorize this term. This terms written as like this. So what is the factorization term for this logic? That is 1 minus 1 by 2 comma minus 1 by 3. So minus 1 by 2 into minus 1 by 3 equal to plus 1 by 6. Minus 1 by 2 minus 1 by 3 equal to minus 5 by 6. This is the factorization logic. After factorization, we can find capital H of Z. Capital H of Z, that is equal to, that is equal to, that time we can substitute this term in this equation. In this equation, the numerator term has 1 minus 1 by 2 into z power minus 1. Denominator term also has 1 minus 1 by 2 z power minus 1. Both terms are cancelled. So finally, we can get like this. This is the equation for system function, that is capital H of Z equal to 1 divided by 1 minus 1 by 3 into Z power minus 1. 1 minus 1. Here we can easily identify poles and zeros from this system function. System function. Then next we can find impulse response of given system. From the system function we are going to find impulse response of given system. Applying the inverse Z transform, we can find the capital H of Z. We know the standard form for the given signal is, when we are taking the inverse Fourier transform for this term, written as a power n into u of n. Instead of a, we have 1 by 3 in our system equation, that is 1 by 3. So applying the taking inverse Z transform in system function, finally we get the response of, that is impulse response of given system H of n. So capital H of Z comes like this, small h of n written as small h of n when we are taking impulse response, that is equal to 1 by 3 whole power n, that is a power n. Instead we can write 1 by 3 whole power n into u of n. This is the impulse response of given system. Then we can find frequency response of the system obtained by substituting Z equals e power j omega. E power j omega. Instead of Z, we can substitute e power j omega, that is h of capital H of e power j omega equal to 1 divided by 1 minus 1 by 3 e power minus j omega. Frequency response tells us, this frequency response tells us how the system reacts to different frequency components. Advantage of Z transform. So the Z transform offers many advantages. It simplifies difference equation. It provides ROC information, that is region of convergence information. It helps analysis stability and causality, and it is widely used in digital filter design. So let us summarize today's lecture. Discrete time systems are described using difference equations. The Z transform converts difference equation into algebraic equation. From the Z transform, we can find system function, impulse response, frequency response. Z transform is an essential tool for LTI system analysis. Thank you.